This video is connected to the November 6th remote class, and in it we will be focusing on raster. This class here is not a raster-based class. We're focusing on vector-based objects, and that's why we call the class Modeling Geographic Objects. That said, this week, and I think probably next week too, I want to give this a little room to breathe. I do want to at least introduce you to some practical applications of raster that you might come across or find valuable in your day-to-day work in planning. That said, those who like these lectures, I cannot state clearly enough how critical it'll be to take Dana Tomlin's follow-up course, Modeling Geographic Space. It is, without exaggeration, the best GIS course I have ever taken. It's challenging, but for those who are willing to work through it, it really, really pays off. So raster, right, modeling geographic space, is different than what we've been doing, which is all about points, lines, and polygons, right, mapping geologic objects. In this, we're not pointing to a point or a line or a polygon, a discrete object, but rather we're breaking the world into a series of grid cells and then mapping some condition of space that's in those cells. And so the way the videos are going to be structured this week is I'm actually, this first one, about to open a PowerPoint presentation or a PDF that I have loaded into the Raster Intro folder. And I'm going to walk you through it real quick to thematically let you know what raster is. Then we'll come into Arc Pro and we'll play around with a couple of rasters. These things in the catalog that look like sort of blue and white grid patterns, right? The elevation and land cover. And then I'll teach you one or two sort of basic processing operations for how we analyze raster. And then, like I said, next week we'll open up these sort of raster tools, more practical application tools that let you run really cool analytics with raster, one of which lets you create the analytical heat maps that we've been able to create visually, and the other, for those of you in development and land use, lets you map the surface of the world, right? So if you have a series of points, you can see what the elevation of the land is, and then you can calculate slope, the way water flows, all kinds of elements that you would be able to calculate if you knew the topography of the land. But we're beginning thematically here. And so you can watch the video or you can even follow along with the PDF that you have. But if you open up the thing that says Raster Intro, this will let me walk through in a little bit more detail what raster actually is before we dive into the tools and the processes. So raster breaks the world into a series of grid cells. And so you can think about raster more like a photograph, or like a piece of graph paper, in which every single cell is the exact same size, and what it is doing is it is depicting you some element of space. Just like with HD TV, or with high definition computers, the pixels can be smaller and represent smaller area. But of course, when that happens, there become more and more pixels, and so the file size of the raster grows. Now, if we were to imagine a vector-based park right here, this is what it would look like. This might be how you would digitize it or rasterize it. And it's important to show that example because sometimes when you rasterize, things can be lost. Right? If your cell size is too large, you might not get the exact shape. And it's important to know that you're not always going to use raster when you want to get the shape of something. Right? The exact shape of something is much better defined by a polygon. You use raster when you want to convey some element of space that can't really be contained in an object. The density of something, right? The risk of something occurring, the elevation of an area, the temperature, the amount of light that is shining in. All of these things don't vest themselves in an object, but they rather are just qualities of space, right? It may be a denser population. You may be surrounded by more buildings or more people in one place than you would another. You may have a greater chance of a theft or an assault in one area because the density of crime is higher. Now, there are three big kinds of analytical operations in raster. We won't learn all of these. We'll learn, like I said, a couple of the more important ones practically next week, and then this week we'll just learn some sort of very basic, how you put two and two together, how you combine rasters so that you have a foundation. But the first operations are called local. Local operations are often thought of as like each cell knows itself. You know, hey, I'm a cell. I'm a park. You know, I have 10% slope. I've got leaky soil. All I know is myself. I don't know anything else that's going around me. And what I mean by knows itself is that you'll see when we start running raster operations, we don't just work with one raster layer, right? We might have 5, 10, 15, 20 different raster layers, each of which represents a different thing. Something may represent elevation, something may represent soil content, something may represent density. But they line up perfectly with one another, just like pieces of graph paper would line up in a graph booklet, so that this red dot here, or this red square, would be the same place in every subsequent grid cell. There are other operations called zonal, and we probably won't do these as much. But zonal really means, you know, I'm in one zone here, and I may not be in the same contiguous area as something else, but we share some quality of space, right? We all have sort of the same thing, and we can process ourselves similarly, even though we are geographically discrete from one another. The final is what's called neighborhood. And these will be the tools when we learn them next week, the sort of practical application tools. They will all be focal or neighborhood, meaning my value is derived from what's going on around me. This is how you create a heat map, right? The density of a point or of a square or of a grid cell can only be calculated by knowing the amount of things around it. What you might pay to buy a home in an area can only be interpolated by knowing around it. The way you would pronounce water or water, like we learned in those sort of early maps on day one, would need to have points around it that you could interpolate. That is a focal operation. Now, all raster is underpinned by something that is called map algebra. And the reason I kept telling you to take Dana's course is because he wrote this. You know, it would be effectively like taking geometry under Euclid, taking a knowledge discipline with somebody who invented it. And map algebra is really the processing language that lets us take multiple rasters, overlay them, and then combine them. And that's what we'll learn a little today. I'll show you the basics of map algebra, how you combine rasters, how you clean them, just so you have a foundational knowledge so that when we get to the practical applications next week, they don't come out of left field and we have context. And so what does it really look like? Right, well, when you have layers of grids and in each grid wants to represent a quality of space, it's where you can start showing things like the density of black residents in West Philadelphia, and you could show the density of white residents. This is actually the Penn Alexander School, and this is the catchment area here, just for sort of reference. So the density of black residents or the density of white residents. You could put one of those on top of each other, divide black residents by white residents, and the area where they were equal, you could almost see the lines of segregation and integration. And it's true for those who are in West Philly. These tend to be the most integrated neighborhoods, at least from white and black populations, is 44th roughly to 47th to 48th. And as you start to head west, the population increases. Black residents, as you start to head east, it increases for white residents. That here is not anything that exists attached to an object, but is maybe the purest definition of what Dana would always call, and what I have repeated to you several times throughout this year, mapping what is not quite there, right? We know that there's a point in West Philadelphia where the neighborhoods are very integrated. We know there's points where segregation begins in one direction or another. But to visually be able to actually see it, density is a tool, and using raster is a way to help visualize. So that's the basic introduction to raster. we'll pick up the next video by opening up the Raster Intro folder, and we'll start to just walk through sort of what raster looks like in ArcGIS and how you start to process it over 2 or 3 videos.